Okay, geometry, welcome to Unit 2. So we are starting with Activity 9, which is all about translations, reflections, and rotations. So today in 9.1, we're just talking about transformations. So we're going to perform transformations on and off a coordinate plane, identify between rigid and non-rigid motions, and they're also going to represent a transformation as a function using coordinates. So open up your book to page 103. We got some vocab coming, so you might want a highlighter in your vocab sheet. But let's go ahead and get started. So we have this situation coming here with Mr. Scott, and he directs the Marching Cougars, the band at, let's just say, South High School instead, since we're Cougars. He uses a coordinate plane to represent the football field. For the band's first show, he arranges the band in a rectangle that is 6 marchers wide and 9 marchers deep. So it's 6, that's not going to work. So it's 6 by 9. So 6 marchers wide, 9 marchers deep. Okay? So the band begins by marching down the grid in this formation. Then marchers move apart from each other vertically while keeping the same distance between marchers within the same row. So we have a picture here of how the marchers are going to kind of do their movements here. So the diagram here shows the initial shape of the marchers. Okay, that's number A. This is our initial shape. And the 2 transformations that they undergo. So here's our first vocab word. A transformation is a change in the position, shape, or size of a figure. Okay? To describe and classify the transformations, compare the pre-image of the transformation to its image. So the pre-image is the original picture. So that would be A. A would be the pre-image. Okay, and then B, these two, B and C, are our transformations, or our images. So using your own words, can you describe what happens in transformation 1? So as we go from our pre-image to image B, what do you think is going on there? So kind of take a minute and describe it in your own words. So this is the answer the book gave me. It's the transformation is a slide or a movement down the coordinate plane. So if we look at it, it looks like this graph just kind of shifted in a downward motion. Okay. Now in the next question, they're going to kind of ask something similar. So go to question 2 here. Compare transformation 1 and transformation 2. How do those compare? So I'm going to go back to the picture here for a minute. So they're asking you now to describe what happens between transformation 1 and transformation 2. So again, kind of describe that in your own words. What do you say is happening? So again, this is what your book said. So you might have something worded a little different, but generally should be about the same idea. So they're saying that the first transformation preserved the size, it just shifted down. But in the second transformation, okay, it looks like that graph got stretched out. So we have kind of elongated picture there. So transformation 1 is an example of something we call a rigid motion. So a rigid motion preserves the size and shape. So all it does is kind of shift left, right, up, down. It doesn't change the shape. Okay. So we'll just kind of skip to that. And then transformation 2, we would say, is something that is non-rigid. Okay, because the picture, okay, the size didn't change, or the size did change. It became bigger in the second picture. So we would describe transformation 2 as a non-rigid motion. Okay, so again, transformation 1 was rigid because all it did was shift down, whereas transformation 2, we kind of had an elongated picture. So that would be a non-rigid. Okay, so we're going to kind of compare some tables here. So review transformation 1. Each point in the pre-image, remember pre-image means the original picture, is mapped here. So the pre-image for image A, they got the 4 coordinates for each kind of vertex of that picture. They want you to complete the table to show the 4 corners of the rectangle in figure A. So you're going to have to flip back in your book and look at the 4 corners in figure A and grab those ordered pairs. So they gave you the first one, 1, 4. So get the other ones that kind of coordinate with our figure A, our pre-image. So if you did it correctly, here's the ordered pairs that I got. So that second one was at 1, -4, and then it was at 6, 4, and then 6, -4. So for any given point, how does the transformation change the x coordinate and the y coordinate? Well, let's kind of look at these. My x coordinates were 1, 1, 6, 6. But in my first image, they're the same. So it looks like the x stayed the same. And now the y definitely changed. So let's look at what happened with the y. So we went from 10 to 4, 2 to negative 6, 10 to 4, 2 to negative 4. So what would you say is happening with the y? What happened with the y for each point, from the pre-image to the actual image in figure B? Well, hopefully you said the y value was, I'm just going to write that it went subtract by 6 each time, or it went down by 6, whatever you want to say, deducted 6. So if we had to write a general rule for this, this is how we would do it. So we would start with x, y, that's your pre-image, and how we would write our kind of our transformation rule as a function. So our x didn't change, so that's going to stay the same. But our y, we would put y minus 6. So what this tells me is the x doesn't change, but the y, whatever that y value is, we would take off 6. So that arrow in the notation shows how it's transformed. It means goes to. So the original pre-image goes to this image. Okay? We're going to do the exact same thing now with our second group of pictures. Now I went ahead and filled in these values for those last two, but we have figure B and figure C now. So here's the points for figure B, so copying those bottom two. But grab those 4 coordinates from figure C, and then we're going to use those to kind of write what happens, and then the end goal here is to write it as a function, a rule here, with our notation. So xy goes to, we're going to figure it out. So go ahead and fill in the table for figure C. Take a second here and pause, and then we'll help us figure out the rule. Okay, so here's my figure C. So it looks like the x's stayed the same again. So nothing's really happening with the x. But what's happening with the y now? So let's look at our y values and compare them. What's happening with those y's? How would you describe that? Okay, well, hopefully you said the y is getting multiplied by a 2 every time. So if we have to write our function rule, we have our x staying the same, but the y, we have to have 2 of them. So that's kind of written as 2y. So that's how we would kind of project one figure onto the other. Okay, so next we're going to practice this. We're actually going to draw some images using the function rule. So again, this just means how they're describing what happened to the transformation. So they're saying A is the pre-image, this red square. They want you to do it so that it moves to x plus 3, comma, y. So think about what that means, and then go ahead and draw your image in. Okay, so if I take this now, I take my square, and our original picture was here. Okay, if we look at this point, that's at 2, 2. I'm going to place my original picture here. But they want us to take our graph and shift it to the right. They want it to be x plus 3. So what that's telling me is we're going to go right 3 with this graph. But we're not going to go up or down at all. So I'm just going to move it based on this one kind of lower corner here. I'm going to go 1, 2, 3. So that's my transformation. So the graph just shifted over. Now, would we describe this as rigid or non-rigid? Hopefully you said that it's rigid. Remember, rigid means the size and the shape does not change. In this case, the size of that that square actually stayed the exact same. Okay. Now I'm going to have you guys try B then. If we have x, y, they want you to transform it so it becomes 2x, comma 2y. So go ahead and try that one now. So if it helps, there's all your coordinates for the 4 vertices. So if I'm going to go ahead and put these in, all I have to do is double my points, right? So it's going to become 2, comma 4. And then we're going to have 6, comma 4. 2, comma 10. And then we'd have 6, comma 10. So here is our figure here. So I'm going to go ahead and put a rectangle in there. So there is our new shape after we transformed it. Now, if we look at the pre-image and this image, would we say this is rigid or non-rigid? Hopefully, again, you said this is non-rigid because the size does change. This gets multiplied by a factor of 2, making it bigger. Okay. So we're just going to wrap up here. I'm going to have you guys try the check your understanding really quick. So go ahead and try these. So number 8 wants you to fill in the table of the 4 vertices of the pre-image. And then we're going to use this rule here. It's going to be x minus 2 and then x plus 1 or y plus 1. So think about that. And then you're going to, in number 9, you're actually going to graph it on the figure below. So go ahead, fill in the chart first. So go ahead and fill in this chart with those vertices. And then we're going to graph it after that. So go ahead and try 9 and 8 really quick. Okay. Me personally, I probably would have graphed it first. I know I can take the figure, just kind of shift all my points. Looks like we're going to go left 2 because it's x minus 2. And then all of our y values up 1. So each point here went left 2 and up 1. So now that I have it graphed, you can fill in the table. Now, if you did the table first, it really doesn't matter, right? But I think I have to use this. So our table, if we filled it in correctly, should look like this. Okay, so again, we took each x value, subtracted the right value, and added 1 to each y value. So we went subtract 2, and then plus 1 on the y, and then go ahead and graph your 4 points. You'll show that transformation. Okay. Okay, really quick, let's have you guys try 10 also. I want you to write the transformation that is shown there. So the x comma y with the arrow. Let me go down here. So I'm going to have you guys write in that rule. So what is our transformation that is shown there on number 10? Go ahead and try that one. Okay, so hopefully you said that the x doesn't change, so the x stays the same, but the y went minus 12. So that was that transformation rule. Okay, so this first one was just kind of talking about basic transformations, how we can kind of shift a figure along a graph. Okay, so just making sure you're knowing what that kind of function rule's telling us. Okay, how they describe the function using that arrow notation. That just means we're shifting the graph either left, right, up, or down. And remember, rigid means there's no change in the shape. So for like number 8 and 9, for example, that would be rigid. Same thing with 10. Anytime you're multiplying here, you're going to be kind of making something bigger or smaller. That makes it non-rigid.